This is section 5.2. We're going to be multiplying and dividing rational expressions. So the first thing we need to do is define a rational expression. It is a quotient of two polynomials. Alright, so basically we're going to be looking at fractions. Okay, here are three examples of rational expressions. Okay, so first up we want to simplify this expression and then identify any x values for which the expression is undefined. Alright, so let's simplify first. Alright, so let's look at the numbers first. 10 over 6. 10 over 6 is the same thing as 5/3. Then the x to the 8th over x to the 4th. The 4 on the bottom cancels out 4 on the top, so we're left with x to the 4th. Alright, and you can write it like this, or you can keep the 5 and the x to the 4th together and put it all over 3. Okay, those two statements are the same thing. Okay, now we need to identify any x values for which the expression is undefined. Alright, in order to be undefined, the denominator would equal 0. Okay, we know we don't want the denominator to equal 0, so let's take a look at this. So we want to think about what value would give us a 0 here. Okay, so the x to the 4th isn't really that important here. We have 6 times what is equal to 0, so that has to be 0. Okay, so in this case we actually want to put a not equal to. Okay, so let's circle these. Okay, so there's the simplified answer, and then we know that x cannot equal 0. Okay, if x was 0, we'd get 0 in the denominator, and we don't want that. Alright. Same instructions, different problem, a little more complex. Okay, so simplify. In this case, when we see a quadratic, okay, remember quadratic means that the degree is equal to 2. We're going to try to factor this in order to simplify. Okay, so let's look at the numerator. Let's see, this is going to factor into get our two parentheses with our x's. We know one is going to be plus and one's going to be minus. Let's see, we wanted to add to 1 and multiply to negative 2. So that's going to have to be plus 2 minus 1. Alright, similar steps in the denominator. Let's see, plus and minus, so we know one's plus, one's minus. Add to 2, multiply to negative 3, so it's going to be plus 3 minus 1. Okay, so it looks like the x minus 1s are going to cross out, and we're left with x plus 2 over x plus 3. Okay, cannot simplify or cross anything else out because of the addition. Alright, so there's our simplified expression. Now we need to identify the x values for which the expression is undefined. So again, we want to look at the denominator. Alright, and I think it's easier to look at the factored version. So we have x plus 3, x minus 1. Alright, and we can't have 0 in the denominator. Okay, which means that x cannot equal, let's see, negative 3, and x cannot equal positive 1. Okay, because those values would give us 0 on the bottom, and we don't want that. Alright, next, simplify and identify x values for which the expression is undefined. Alright, so let's see. First thing that we want to do here, we want to write the x squared first. Okay, so that negative x squared is going to go out front, plus 4x over x squared minus 2x minus 8. Okay, you always want to have it in standard form. When you are simplifying, it just makes things easier. Okay, so in the numerator, you want to take out a negative x. Okay, if there's a negative here with the highest degree term, you want to factor that negative out with it always. Alright, if we take out a negative x, we're left with x, and then we're left with a minus 4. Alright, remember, anytime you factor, you can always check by redistributing what you took out. So if we multiplied these two, we would get negative x squared. If we multiplied these two, we would get plus 4x. Okay, and that's what we started with, so we are good. Alright, so here on the bottom, let's factor this. Alright, so multiplies to negative 8, adds to negative 2. That's going to be minus 4 plus 2. Okay, and look at that, how nice x minus 4s are going to cross out. So we're left with negative x over x plus 2. Alright, so there's our simplified version. Now what we want to do is find the values for which, for the x that will give us undefined. So we're going to look at the denominator again. Alright, so we have x minus 4, x plus 2. Alright, so let's see, x cannot equal 4, and x cannot equal negative 2. Alright, so that's just simplifying rational expressions. What we're going to look at next is multiplying them. And here are the steps for multiplying. Factor the numerators and denominators, like we've been doing. Divide out common factors. Multiply. And then just go back and check and make sure that you simplified everything correctly. Alright, so let's see. Multiply. We're going to assume that all expressions are defined, which means there's no zeros in the denominator. Alright, so let's see. There's a few steps here. Let's start with the first expression. Let's simplify before we multiply to keep our numbers a little bit smaller. Alright, 3 and 2, can't simplify there. Let's see, this x cubed is going to make that an x squared. This 3 will cancel out 3 of these. Alright, so we have 2x squared over, oh, sorry, that should be a 3. 3x squared over 2y to the 4th times, let's see, 10 and 9 can't cancel. X squared is going to leave just one of these, and y to the 4th is going to leave just one of these. So let's see, 10x over 9y. Alright, so now let's see if we can simplify anything. Let's see, the 2 can simplify the 10, and the 3 can simplify the 9. Okay, I think everything's simplified. Now we just multiply across. So the numerators, let's see, 5x to the 3rd, right, because we had x squared here and x here. And then on the bottom, we have 3, and then y to the 4th, and 1 is 5th. And there's our answer. Okay, let's move on to B. Let's see, x minus 3, we can't simplify that. But let's see, this is a 4 here is a greatest common factor. We're left with x plus 5. And then let's see, x plus 5 up here. Here we have the difference of 2 squares, so that's going to be x plus 3, x minus 3. Alright, now let's look and see what we can cancel out. X plus 5s, x minus 3s. Alright, I think that's it. Now when we look, we canceled out everything in the top. Okay, that doesn't mean the top goes away, it just means it simplifies to 1. Okay, over, let's see what do we have left, 4 times x plus 3. Okay, and you don't need to redistribute the 4, you can leave it just like that. Okay, a couple more. You can do similar process with 3 terms. Let's see, x over 15 can't simplify. Let's see, this x can make this a 6. And then, let's see, nothing here. Okay, so now let's see if we can simplify diagonally. Let's see, nothing here, I don't think. Right? How about here? This 2 can make this a 10. This x to the 4th can make that an x squared. Okay, so now let's multiply to see what we have. So that's going to be x to the 3rd and the 10, so 10x to the 3rd over, let's see, these both all crossed out, so it's just over 15. Alright, now check and look at this. 10 over 15 we can simplify. Alright, so let's make that 2x cubed over 3. Okay, right, because 10/15 is 2/3. Alright, our next one here, let's see, it looks like we can factor some things. We could take a 10 out here, x minus 4. Alright, here's a quadratic. Set up our parentheses. Let's see, this is going to be minus 4 minus 2, right? Adds to negative 6, multiplies to positive 8. Okay, let's see, x plus 3. It's here. Let's take out a 5, and we're left with x plus 3. Alright, so now let's see what we can cross out. X minus 4. X plus 3, and then this 5 and 10, got a 2. Alright, so it looks like 2 is the only thing left in the top, and x minus 2 is the only thing left in the bottom. Alright, moving on to division. Dividing, very similar to multiplying. Remember that when you divide by a fraction, you really just multiply by its reciprocal. So this is going to be 5x to the 4th over 8x squared y squared. Change this to times and write the reciprocal. 8y to the 5th over 15. Now it's just like the problems that we did before. Okay, so let's see what we can cross out. Those 8's kind of jump out first. Let's see what else. X squared makes that an x squared. Y squared makes that a y to the 3rd. And let's see, 5 and 15. Alright, so let's see what do we have left in the numerator. X squared, y cubed, over, let's see, everything's gone there. Looks like it's just over 3. Okay, can't simplify anything else here. So we got it all. Alright, here is the last one. There's a lot to this one. Okay, so what I want you guys to do, you're going to rewrite it as multiplication by multiplying by the reciprocal. There's a lot of factoring. Alright, so go through, factor, see what can cross out, and see if you can come up with the correct answer that we will check in class tomorrow. And take a few minutes for that. When you're finished, go on to the next page. Alright, a little bit different here. We are solving and checking. Okay, so in order to do this, let's factor the numerator first. Let's see, this would be x plus 5, x minus 2. Right, because 5 and negative 2 will give you 3. When you multiply, it gives you negative 10. Alright, x minus 2 on the bottom. Alright, now this is nice. The x minus 2's cross out. So x plus 5 equals 7. So x equals 2. All right, now after we do this, we go back, we look at our equation, and think, can x equal 2? Okay, well, if we go back here, if x is 2, we're going to get 0 in the bottom, and that's no good. All right, so we're going to actually say this has no solution. Okay, let's try one more. Let's factor the top. It's a difference of 2 squares. 2x plus 3, 2x minus 3. All right, so let's see. 2x plus 3s are going to cross out. 2x minus 3 equals 5. Add 3, so 2x equals 8. Divide by 2, x equals 4. Okay, so now let's go back to the denominator. Can we plug in 4? Yes, that's not going to give us 0. All right, so x equals 4. There's our answer. All right, now since you've made it this far into your video, here is your joke. Why does Snoop Dogg carry an umbrella? Faux drizzle.